Okay, so today I'm going to talk about how to do something called RAG analysis on news. So if you're doing any kind of research for your company, research for a particular topic, in my case, I do a lot of research for news articles on the mineral and mining industry on a weekly basis. And I wanted to create a way to quickly digest all the information and create a summary. And I also wanted a way where instead of just scrolling through Google's search results and reading the highlights, I wanted to have an AI system be able to extract content relevant to the questions that I have about particular topics. So let me show you how to do that today. So you can see I'm in Colab and I've got a simple CPU instance. And the reason for running the CPU instance is we're going to be using OpenAI. Now, naturally, if you're doing this in your own company in a closed setting, maybe with personal data, then you would likely want to use an open source model, but then host it on your servers or maybe through a different third party, and then have a closed circuit so you don't send information out to OpenAI. But in our case, especially if you're just doing some basic research and you want to stub out an idea and see if it works, I find often the best thing to do is just use OpenAI to see that it works, and then you can move over to open source. So we've got our prerequisites installed. We have ChromaDB, which you'll see in just a second is essentially a way to store the data in a vector format, and that simply means numbers, so that we take the text that we're going to generate from web searches and convert it into a vector form. That'll be important for doing similarity analysis. When we ask questions of the news, then we can get back relevant answers. I'll show you how that's done. We also have LangChain, which essentially is just a way to interact with large language models. Provide some convenient features, classes, and that help you do input-output. And we have some typical things like pandas. We've got the OpenAI API. We're going to be doing some web scraping, so I've got Scrapy, and I've got DuckDuckGo search for doing simple searches. Now, I've written this notebook to help you adopt some open source language models. You can see here there's some instructions for installing them. I won't do that here, but I leave it to you as an exercise. If you just run these commands, you can see what Llama can do out of the box without any fine tuning. So let's get started. We've got some imports here, and then we jump right into web search. So if you've never used the DuckDuckGo interface, it's really simple. You just say DuckDuckGo search, and you write your query. And so in this query, we're going to do some things that I do with the mining industry, for example. And I'm looking for anything that has the word mining, mineral. I want to exclude terms that have text mining, Bitcoin, crypto. Obviously, those aren't relevant for what I want to research. And then I'm also looking for topics that have to do with artificial intelligence. So the way that this works is I'm going to perform the search, and I'm going to limit it to weekly results. So I should get the last 7 days, and I only want 100 results. We'll stuff that in a data frame, and then we'll do some post filtering just to make sure that we don't get any content in there that's older than a week. So if I just run this, great. So we have 23 records, and it looks like we have columns, date, title, body. Let's just take a quick look at that data frame and its news search. So like tail, just to see what it looks like. So we have the date time, we have the title, we have the body, the URL, which we'll be using for web scraping. Sometimes you get an image with Google search, you'll definitely get an image, which actually helps quite a bit, and then the source. Obviously, you can filter on these more if you're interested in doing something a little more custom yourself. But what we're going to do is simply take the URLs, and we want the actual text from the website so that we can do our RAG analysis. So we're going to use Scrapy, and if you've never used Scrapy, it's just a scraping engine that's been around for a while. We're going to use Scrapy-Do to run it inside of the notebook, and then we're going to take the HTML that we get back from the web scrape and convert it to text. And we'll show you that. Here I have my scraping spider. I have a simple mining search text, and I'm going to create a field out of the text. And then in the spider, I have this parse function which simply creates a new field and then grabs the response, the HTML response that comes back from the scraping engine. And then it's going to send that back to us when we're done. So we'll run this cell, and then we have our URLs that we want to scrape, which is those new search pandas data frame with the URL column. We want to make a list out of it. Scrapey-do is going to get things set up for us, and then we're just going to run the spider. And I find it's usually pretty quick. Oh, interesting. I'm not sure what the error there is, but it looks like it did return some results. I'm going to ignore it for now. Anyway, I found that if you run the spider from a notebook, usually it's pretty quick. You're going to obviously miss some results. This is a very bare bones scraping setup. You would not want to do this for production. But again, it does allow you to see what's possible. So if we just look at the data that we get back, we have those response. We have a code 200, which in HTML means we got a response back from these sites. So we have Forbes, USA Today, Politico, Finance Yahoo. Some of these should be pretty familiar. Some of them are kind of odd. I've never heard of these. Irish Times, I never look at. But anyway, we have the data. And now what we have to do is extract the actual text from the response. You could do this in the parse function. I've just split it out for you so you can see what's happening. Okay, so we've taken the response object out of the text dictionary and we've returned those. And then the next thing we want to do is take the actual text element out of the response object. And if we run this, we have the actual text. And then I'm going to do something really simple. I have this helper function, safe apply, because sometimes when you try to use HTML to text, a common library, on raw HTML, sometimes you'll get errors that are cryptic and you can't really understand what they're telling you. But I find it's usually best just to take a really simple approach, and I'm going to say if there's an error, don't do anything. So I run that. And then I'll run the safe apply, and let's see what text data looks like afterwards. So all of the HTML has been stripped, and now you have the content from the HTML page. This one more thing I'll do, which is to just strip out some new lines, just as a measure I found was helpful when I did this the first time. The next thing I want to do is take the text that I have and combine it with the actual URLs that gave us the text. That way, when I do the RAG analysis, we can combine the two and we can reference back to the link that gave us the text. So if I just run that, you'll see on the left-hand side, we have a URLs column where we got the text from, and then the HTML to text conversion on the right. So the next thing we need to do is transform the data. And that simply means convert the text into numbers. And those are called vectors for natural language processing. And it's actually a really simple task to do when you're using LangChain and Chroma. So we have these helper functions, data frame loader, a character text splitter, and a document. So let's see what a single record looks like. It's actually quite large. The first record, let's get the text element, and let's see if we can expand it. So we have a ton of information. So we can't just use the text the way that it is, because first of all, it's too big. You wouldn't just throw this at the large language model. Instead, you need to break it down into smaller chunks, and then those chunks will be vectorized or turned into numbers. And the way that we do that in LangChain is we have a data frame loader. We're going to give it the data frame that we have, and we're going to tell it that the page content column is this text column that you saw above. And then we're going to split those documents into much smaller sizes that are manageable to a vector database. And that simply is using the recursive character text splitter from LangChain. And we won't go over what chunk size means or chunk overlap. I'll leave that to you as an exercise to research. And then we will perform the splits. So that's done. And then we need to create a database. Again, a really simple way of doing that is to use Chroma. It's a very popular open source vector database system. And in order to create the database, we need to, again, transform the information into vectors. And we're going to use this sentence transformer embeddings model to do that. So let's run these, and let's get the embedding function, which we will use. Oops, model not found. Okay. So I need to install, I guess I did not install that in the pip install. So let me do that. Okay, so that's finished, and now let's see what happens when we run this again. So while we're running this, this model here, all mini LM, L6, V2, etc., you can find a lot more information about this model or other embedding models if you just go to Hugging Face. So let's see what we can find. That's going to take a few minutes to download because those models can be pretty large. But let's see if we can locate anything on this model. Okay, so we just do a quick search on Hugging Face, sentence transformers. So you can read about what it does. It maps sentences and paragraphs to a dimensional space, vector space, and can be used for tasks like clustering and semantic search. So exactly what we wanted to do. This is a really popular one. Okay, so we're done loading, and just close that. And then we're going to create a database, and what we're going to do is just say chroma. We say from documents, which is the method that we call to load and generate the database. We're going to give it the data, the split data that we created just a moments ago, and then the embedding function, which is going to take the data and convert it to numbers. I generally find for simple data sets like we're using here, a weekly web search, something very simple, a couple PDFs, you're looking at maybe 2, 3, 5 minutes max to create the database. Okay, the database is finished, and now we want to see what we can do with it. So remember I said that a vector database allows us to do similarity searches on sets of data. And the similarity is going to be created by the question that we give to the database. So in our case, we're setting up a query, and that query has several topics: artificial intelligence and mining. So it's going to take that query and it's going to compare it to all the text that we split out and converted to number format. And in Chroma, you have this similarity search method that will take your query, and then you can tell it how much information to send back. So you can actually dial in the amount of data that's going to be sent to a large language model to reason over. So when we run it, you can see that it's a list of these document objects that it gives back, and provides us a set of text essentially for the question that we asked. So that's one document, another document here, another document here. That's 3, 4, and 5. Let's just see, does it make sense? Is it related to the question that we ask? If we look at the page content attribute in the mining and metals industry, artificial intelligence has great promise, blah, 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 and a bunch of data. So that's pulled back something that seems reasonable. And this next document, improving efficiency, energy and water, minimizing environmental impact, use of artificial intelligence has promise for improving resource efficiency, etc. Okay, great. So it is pulling back information that seems relevant to what we're going to ask. So if you wanted to just use this as a way to sort through the news and find the stuff that's most interesting, you can filter down to the links that make sense that you want to click on and then go read. But actually you can do a whole lot more. So in my case, I want to use the AI to actually summarize and explore the news and then pull out content that is relevant to the things that I'm looking for. So I want to show you how to do that. If you're using open source models, again, I've provided you some helpful commands to run through those. But again, we're going to use OpenAI. So let's just delete this one here. I'm going to use LangChain again. As I said, LangChain allows me to interact with language models, OpenAI being, ChatGPT being one of the language models. So let's just load that in. I won't explain the rest of this here. We'll just run through it. This is all explained very well in the documentation, but it's really not super important. What is important to understand is the process for how you organize the RAG analysis. So in RAG analysis, you have the documents store, which is the database. You have a retriever, which is the database method similarity search. And there are many ways to do that, but in this case for Chroma, we're just going to use that. And then you have the large language model, which allows you to take that data and then reason over it. And the way that we do that in LangChain, first of all, we have to set up our OpenAI API key, and then we need to set up our chat model, which is, we're just going to use GPT 3.5 Turbo, sufficient for what we want to do. I'm going to comment out this OLAMA, we don't need that. Okay, so we've got OpenAI set up, and the next thing we want to do is create what's called a retrieval chain. LangChain has essentially a set of pre-formatted ways to interact with large language models. In this particular one, we're going to do a QA, question and answer, and ask the system to retrieve information, put it into the large language model, and then ask a question about the information that we gave it. So I have a retrieval QA, and I say, here's the chain type. I have the large language model that I give it, and I give it the retriever, which is the Chroma database, and I say as retriever. That's fast to set up. And then, so now we can use that model to give us summary answers for questions that we have. In this case, we're just going to ask which companies are mentioned in the context of artificial intelligence. And when we run this cell, companies mentioned are C3.ai, NVIDIA, Amazon, Microsoft, Upstart, and Fair Isaac. Interesting. Okay, so it's pulling information out for us. So if we want to see what the AI model is going to get when we send it documents, we can create this retriever, which is just the Chroma database with the as retriever method, and then we can use it to down here to get relevant documents from the question that we're asking. So we've done this up here, but in this case, we're actually going to just take those documents, format them, and join them together with some new line characters, extract the page content, and then just join it together with some new line characters so that we can see what it's actually giving us. So if we run this, essentially we have a set of strings of all the content that's being delivered by the database that's relevant to the question that we asked. So now we can take that content extraction method and use it in what's called a prompt template. So remember, I said that RAG analysis requires us to have a database, a retriever, a language model, and then this is one extra component, the prompt template. And that prompt template allows us to give some instructions, context, and other information to the language model to give us back exactly what we're looking for. And the prompt template allows us to parameterize what goes into the language model. And the way that we do that is with some brackets. We have system, instruction, and context. So the way that you typically prompt a language model is give it some system commands, which are high-level commands, the specific instruction that you want the language model to perform, and then if you have examples for it to review or to produce content from, you can give it that context in this prompt template. So we're just going to run this and ignore it for now. So now in LangChain, we can take these objects and create a pipeline out of them. And that pipeline allows us to take the instructions for the language model, the systems level instruction, and the context for what we're wanting the language model to do, to pass all of that into the prompt, so it will format the data for us, and then pass it to the large language model. And once the language model returns the results, it will essentially give us the string that the language model produces. So now we can use this chain to ask some really interesting questions. So in our first case, what kinds of AI concepts and applications are being used in mining? So that question will be passed to the retriever to get the context. You've seen that up here. And then we'll produce the formatted context. So let's ask a question, what kinds of AI concepts and applications are being used in mining? And then we can get the context back from the database, which you saw up here. And then we're going to also format that context so that when we're done, we have basically a set of documents that have been smushed together, and we can use that now to ask the AI to perform some tasks for us. So my system command to OpenAI is, you're an expert news summarizer and you've got the personality of Steve Jobs. And I want you to use the context, this is the instruction, and create bullet points summarizing the important parts of the information I'm going to give you. Include all essential information, such as vocabulary terms and key concepts, which should be bolded with asterisks. Okay, so we can actually give it formatting instructions. And remove any extraneous language. Focus only on the main aspects of the passage or the topic. Base your notes strictly on provided text without adding any extra information. So remember, for that prompt, we're going to give it the context, we're going to give it the system command, and we're going to give it the instruction that we want it to perform. So let's see how it does. It should take only a few seconds. Okay, so we have, looks like, didn't do well. I guess those count as bullet points. So AI has great promise for improving resource efficiency. AI applications can support increased energy efficiency maintenance, productive scheduling, defect detection. Decision support systems can analyze data from sensors and cameras to spot problems, etc., etc. Looks like it's doing a pretty good job of summarizing the text. You can, if you want to, in your own application, what you would do to verify that is just to take the context, remember, which is just the retrieved information, and read over it yourself just to make sure that it's actually capturing the key points of the data. Another thing we can do is ask, for example, sentiment about the content. So in this case, the system command, you are an expert social scientist and marketer, and you're going to evaluate sentiment. Organize the concepts described in the context provided and assign them a sentiment score of 0 to 5, with 5 being positive and 0 negative. And then for each score, include your reasoning for the score. So let's see what we get with that. So the concepts described in the context are as follows. AI applications in mining and metals industry has a positive sentiment score of 5. I wouldn't expect anything less. Improved resource efficiency, again, sentiment score of 5. And you can see that for each one, it's giving you its reasoning as to why, and then provides an overall, here's the positive sentiment for this particular topic. Okay, so the next thing we want to do is see if we can extract entities. And the system command I have is, you're a professional web researcher, and you extract names of companies and people from web articles. And the specific instruction is, list the names of the companies in the provided context, if there's any, and then where possible, list the names of people mentioned from the company. So again, we're on the topic of artificial intelligence, so we want to grab the names of the companies. A lot of them are going to probably be startups that we might want to follow if we're a large company, for potential acquisition over time. If we're a smaller company, maybe for partnerships that we're looking for. And then we want to find out, for those companies, who are the people that we should connect with. Maybe I can open up LinkedIn and then start a conversation. Let's see what we get. All right, so several companies mentioned. Copper Development Association, I've never heard of them. Keith and Oliva, Corrigan and Lay. I would double check. I've had mixed results with entity extraction. Now, there are ways that you can improve the results you're getting by giving some examples in the context, but that's beyond the scope of what we're doing here today. And the last couple things I wanted to show you, one is, let's say that you're reading the news, and what you want to do is actually get some ideas for your company of how you could use the concepts presented in the news and then develop a solution for your company. If all you want to do is maybe start thinking more broad scope of what's possible, you could use the collective knowledge of the language model to help you reason over what's possible and then compare it with actual stories in the news of how people are using the systems today. So we're talking about artificial intelligence. The system command I have is, you're a Google principal engineer, and you're tasked with reverse engineering a concept described in the news. And I want you to pick a concept described in the context provided, generate a software concept that will work on drones, and then create an outline for the concept and produce some code templates that our software team can later start filling in. So if you're a manager, or if you're simply developing your own projects. And if you want a really snappy way to come up with ideas and stub them out quickly that you can show somebody else and say, call a meeting and say, 5 minutes, tell me if this is going to work or not. This would be a really simple way to do it. So we run the command and we're going to get some results. Looks like it picked just one concept. Yeah. Okay. So AI-powered drone surveillance system for mining operations. Interesting. I happen to know that this is actually an active project that many companies are already doing. Explain the need for efficient surveillance, introduced the concept of using drones, and then highlight the potential. So it goes into detail about system architecture, drone hardware and software, different algorithms, processing and analysis, communication, user interface, and then code templates. So let's see. The code templates, so it looks like it did a pretty good job of giving me an idea with a breakdown of what I need to do to get it implemented. But the code templates, I would actually go back here and tell it to provide maybe specifically some Python or C++ templates. But it looks like it's doing a really interesting job of really actually quite accurate of what you would need. It even mentions model names that you would use to do, for instance, object detection. So the last thing we want to do is pretend that the AI system is an elite AI researcher. So imagine that you're a manager for a company and your boss comes to you and says, hey, I'm hearing a lot about this new AI stuff and I want you to present on it. And imagine that you only have a very surface level understanding and you're not really sure what's happening in other companies. You could take the news like we've done here, create a digest of the ideas that are being discussed, and then use the AI model to generate a list of concepts and facts presented in the context, and provide some expert descriptions so that you could take this back to your group and present something that would not only be accurate, but also interesting. So we run the command and let's see, concepts and facts. Concepts, artificial intelligence has promise for improving resource efficiency. So it gives a description. Applications in the mining and metals industry can support increased efficiency, predictive maintenance. It analyzes data from sensors and cameras, AI-driven decision support systems, insights. Okay, so it looks like it's giving me kind of halfway decent answers on some of these. I could obviously use ChatGPT or whichever model to dig in more, to ask an additional questions. But I do like the fact that it's giving me more detail and then actually going over the common misconceptions. That actually can be quite useful. That's just a quick overview of what's possible with using large language models to analyze the news on a weekly basis. Some of the other topics that I'm interested in and will be showing in other videos are things like reasoning over images, specifically satellite and drone images. Another topic is really exciting to me, which is the concept of AI agents. So you can actually have the language model perform tasks for you, including the things that we've just discussed here today. So you can create essentially your own personal assistant that focuses just on the topics that you're interested in on a daily, weekly, hourly, whatever you want basis. Thanks for watching. I hope you give a like and a subscribe. And if you have any questions or other things you'd like to see, please reach out. You can find me on LinkedIn and also on Twitter. Links in the video and links in the notebook.